Hello and welcome to Lecture 1 of Math 1B03 Linear Algebra for McMaster University for the Fall 2020 semester. It may be possible that you're not at McMaster or you're watching this in a future time. In either case, to people in the fall semester 2020 or other places or other times, welcome to these collection of lectures. Now, these lectures are all based upon the class textbook, which is Lay, and McDonald's textbook, Linear Algebra and its Applications. That's the 5th edition. You can use that one, or you can use the 6th edition if you can find a copy of that. And in this course, we're going to be talking about kind of the basic objects of linear algebra. We'll be talking about linear equations, solving system of linear equations. We'll be looking at matrices, and then we'll be looking at some of the properties of matrices. Then we'll be looking at what vector spaces are. And at the end of this course, we're going to be looking at eigenvalues and eigenvectors. Now, I posted all of these videos on a YouTube channel, and they're also part of the McMaster Avenue to Learn shell for Math 1B03. So each lecture that you're going to watch are going to come down to the same format. I've broken each lecture down into 3 to 4 pieces, most pieces about 7 to 10 minutes long. And it's recommended that you watch each of these lectures, watch about 3 lectures a week. Okay, so you have to watch 9 to 12 of these videos per week. And each lecture, I kind of explain what we're going to do, and we'll kind of work through kind of some examples, the definitions, and in some cases, the proofs. And before I go any further, I should just actually formally introduce myself. My name is Adam Van Tool, and I work at McMaster University. My area of research is in abstract algebra, so I'm very interested in linear algebra because it influences my own work, and I also think it's a very nice and beautiful subject. So I hope you enjoy these lectures, and we're going to start today with lecture 1, talking about systems of linear equations. So I'm going to start off by explaining the basic object of study, linear equations. And kind of today's lecture is more to kind of give you a feel of what we're going to be doing in linear algebra. And then we're going to dive deeper into some of the topics as when we move on to lecture 2. So let's make myself disappear here, and we can kind of formally start our lecture for today. So the basic object of study in this course are linear equations. So a linear equation is any equation that looks like this: a1 times x1 plus a2 times x2 all the way up to an xn is equal to some number b. And the numbers a1 through an are called the coefficients of our linear equation. So these are the coefficients. The x1 through the xn are called our variables. And what we have is that each of these numbers, a1, a2, up to an, and the thing that it's equal to, are either going to be real or complex numbers. Are real or complex numbers. Now, for the majority of this course, they're actually going to be real numbers, and we'll talk about complex numbers actually when we get up to a lecture 33 or 32, around there. So a long time before we'll see complex numbers. And let me just give you some examples to help illustrate. Oops, didn't mean to do that. Let's get rid of that. I meant to use my moving tool. Let me give you an example of some linear equations. So first of all, I'll give you an example of a linear equation. So 3x1 plus 2x2 plus 20 x3 equals log 2 of 17. So this would be an example of a linear equation. This is a number. We have all numbers, and all the variables only show up to some power. But if I had something like this, 3x1 squared plus 2x1 times x3 plus sine of x4 equaling to 8, this is not a linear equation. And there's a bunch of reasons it's not a linear equation. We having variables multiplied by other variables, or powers of variables, or we have like these functions here. We're taking sine of a variable. So these things are not allowed when we look at linear equations. And one of the main things that we want to study in this course are systems of linear equations. And what is a system of linear equation? It is a collection of one or more linear equations. So a very simple example of a system of linear equations would be something like this. 3x1 plus 2x2 equals 3, and negative x1 plus x2 equals 4. And let me just call this star so I can refer to it in a minute. So here we have two linear equations, and I have two variables. So this is a system of linear equations, and what we're interested in is finding solutions to a system of linear equations. So what do we mean by a solution to a system of linear equation? Well, it's an n-tuple. So what is an n-tuple? Well, that's just a collection of numbers, s1, s2, up to sn. So it's a collection of n numbers that makes each equation true, that makes each equation in the system of linear equations true after you replace xi with si. After you replace xi with si. So let's make this a little bit more concrete. If I take the pair, this would be a two-tuple because I have two elements. If I took the pair negative 1, 3, well, this is a solution to my system of linear equations that I had before. And let's see if I can get both of them on the screen here. I'm not sure if I can do that. Let's see. No, it vanished. But here, I'll just rewrite the solution down here. The solution was S1, S2 equals negative 1, 3. And you can check that this is true because when I replace x1 by negative 1 and x2 by 3, I get 3 times minus 1 plus 2 times 3 gives me 3, so that's true. And minus 1 minus 1 gives me 1 plus 3 is 4. So when I plug in negative 1, 3 into both equations, all of the equations in the system of linear equations are true. So this was a solution. And so we can talk about the solution set of a system of linear equations. And a solution set is going to be the set of all solutions, right? So the set of all solutions to a system of linear equations. So you're given a system of linear equations, a bunch of linear equations, and then you want to know what are all the solutions to that system of linear equation. And we say that two system of linear equations are equivalent if they have the same solution set. Same solution set. So I'm ending the first part off here with kind of two fundamental questions in linear algebra, especially in a first year linear algebra question. So given a system of linear algebra, we can ask, does a solution to the system of linear equations exist? So can you actually find a solution? There are going to be scenarios where the system of linear equation has no solution. And if a solution exists, is it unique? Is it the only solution that you can find? Is it unique? So these are kind of like two fundamental questions, and these questions appear throughout the course in various disguises. So we'll start with one particular problem, which may not seem to have anything to do with this, and we'll transform our problem into a question that really boils down to, does the solution have does the system of linear equation have a solution, or how many solutions does it have? And these two questions appear throughout the course. So keep these two fundamental questions at the back of your mind. We'll take a pause now as I get ready for the second part of today's lecture.